Oh, oh no, Mimi. Mimi. So the first thing we got to do is in GIS, we have topobathymetry and an aerial base. So in graphic studies 2, the last tutorial that I gave, I shared this here, orthoimagery data download, this shapefile right here. So what that basically is if you pick a site, so let's pick Vera's site. And if you pick a tile, like let's say this one right here, and then you can download from this list here, a high resolution tile from the Department of Transportation of Louisiana. And the one that is of the highest quality is this one right here, this Y2014 B03. And just click on that link and then it'll automatically download it from whatever web browser you use. And the reason we need imagery is because a site model is essentially 3 things: topography, imagery, and then structures. So you can see this image here is really, really, really nice. You can go in here and you can basically go to the scale of the block. So I'm going to bring in this one here, and I'm also going to bring in the one adjacent to it. First thing we do is we establish kind of like a project extents. And so what we're going to do one of your project folders. And then in here, I'm going to create a new shapefile. I'm going to call this one site bbox. In the coordinate system here, we'll use the current map NAD 1983 Louisiana South coordinate system. Then choose run. So then that creates a bound box there. Then we're going to do is we're going to click on that feature there, go to edit, go to create in the edit tab. And then on the right side should be a create features window that comes up. Click on that feature there. Click on the rectangle tool to draw a box that kind of represents a site, and then just essentially draw a rough area that you want to build a model for. So let's do something like this. So that's going to be the area that we're going to build a model for. Hit save and the edit tab there to finish that, save. Let's start with the terrain file. What I might recommend for some of you, especially for sites like this, which are fairly large in size, use the 2-meter resolution instead, because it will be less processing intensive and hopefully will reduce some of the issues some of you are having with the models being too big and crashing. So what I'm going to do is I'm going to zoom into this area here. And then what we're going to do is we're going to export out a little portion of this DEM here. I'm going to right click on the 2-meter topobathymetry layer, go to data, export raster. In the output raster data set right here, I'm just going to click on this browse button right there. I'm going to go to the demo folder, wetland site topo.tiff. Save. And then in clipping geometry, this line here, make sure that's set to current display extent. Then choose export. And there you go. So now you've created a little clip. So that's our topo. We have our aerial images as well. And then what we also need is structures. So I'm going to turn on building footprints. So I'm going to run through this process again, really, really, really fast. So I go to map, select by location, building footprints, site bounding box, hit OK. Right click on building footprints, go to data, export features, click on that folder there, wetland site buildings, and click OK. You go into geoprocessing. Go to feature to point, click on that function. In input features, you choose the wetland site buildings. Output feature class, leave as is. Then choose inside, choose run. Go back to geoprocessing, add surface information. In input features, you choose the feature to point. Input surface is going to be that NOLA LiDAR 2017 DSM. Output property is going to be Z. Then choose run. Search for join field. Input table. This will be the original site building shapefile. So wetland site buildings. Input join field will be FID. Join table is going to be the feature to point. Then in join table field, this is going to be the original FID. Then in transfer field, that's going to be Z, and choose add and choose run. You now have a Z value right there. That's the building height. In InfWorks, we're going to create a new model. Choose new, blend site, then check work local. And then in coordinate system there, we're going to choose UTM-8415N. And then in model extents, check define model extent, load extent from file. And we're going to choose wetland site topo TIFF file and click OK. So now we have the extent of that site there. Before we even add any data to this, we can now also trim this area to that bounding box. Go to the model properties. So in the manage tab at the top of InfWorks, you choose model properties, define the extent by using this load extent from file button there, and go find that site bounding box shapefile that we created. Then use first polygon and click OK. Now you've trimmed it to that bounding box. And now you can begin to add your layers. So first layer we add is going to be topography. topography, go to the data sources on the right, choose raster for the data that you want to add. Now we're going to add the wetland site topo TIFF file, and then double click on that to configure it. In coordinate system for the topo data sets, we use the UTM-8415N. Some of you, I've run into this issue where you might not actually have the full window visible within your InfraWorks page. When you do that, you can always just hit enter and it just works as well. And then refresh the file in the data sources to have it model itself in 3D. Now you've created your terrain of that wetland site. Now we're going to add the aerial images. Click on raster, data sources, raster. Now we're going to go into the folder where I saved those ortho images. We choose 8719 and 8919. Click open. So we double click on that. In coordinate system, that's again the UTM-8415N. Then choose close and refresh. So now we've added the aerial image to the model with the terrain. Now let's add the structures. Go to the drop-down menu, add a shapefile, wetland site buildings. It's our shapefile. You double click on the building shapefile layer to configure it. In type, it's going to be set to a building. In roof height, you go into the expression editor right there, choose the numeric value Z. In the units, we hit meters, check this roof height above sea level. In style, choose the little pencil, go to color, choose a white color, and just copy that white color code into the rest of the style variables there, then choose close and refresh. Now I've created buildings. You've created a site model of your project. The dimension that I put into the assignment sheet is a little bit incorrect or inappropriate. And so let's just put it this way. In fact, for a lot of you, it might actually significantly more than 100 feet, maybe even 500. So I'm redacting that part of the assignment from the assignment brief. Like 100 feet, that's a little portion here, when in fact, you really need to go for that site scale sections. How do I know when I bring in the, say, for instance, the terrain topo, that I need to choose UTM-8415N? You go back into GIS, you need to examine the actual properties of the data itself. Click on the layer that you're adding into InfraWorks, right click on it, choose properties, go to source, and go to spatial reference. And you see right there, that is the coordinate system that is associated with that particular data set. One additional layer that we need to add to this is the roads. So what you do is just clip it. So go into geoprocessing, type in clip, and then we're going to choose the first clip. In input features, we choose the edge of pavement poly. In clip features, we're going to choose the site B box, and in output features, we'll just simply put that into the demo3 folder. We'll call this one roads wetland site run. And there you go. So if you turn that off there, now you just have the roads for that site. And now you can go into InfraWorks and then add a shapefile in here for roads wetland site. So you configure that, double click on that. In type for this particular data set, we're going to add it as a coverage area. And then in style here, choose that pencil, go to material, colors, transparent, and click close and refresh. And this will come in handy when we bring this into Rhino, because what you've essentially created is a cutout of the road feature in the model right there. And that'll come in really handy for when you need to cut sections, because it actually is essentially extracting out a road layer from this. And this is me just kind of winging it. So I'm gonna click on that, download the aerial for that. 724. Building pyramids. Okay, this is great. For Aaron's site, let's create a site bounding box. So right click, new shapefile, call this one Aaron's site bounding box. Coordinate system is going to be current map, run, go to edit, create, Aaron's site, rectangle. Then save that, save, clear. And then we're going to export topo. So let's turn on the topo layer. Let's again use the 2-meter resolution, right click on that topo, data, export raster. We're gonna call this one Aaron's site topo, save. Then in clipping geometry, current display extent, export, and then there it is. And then structures as well. Select by location, Aaron's site bounding box, apply, data, export features, Aaron's site, addresses, save. Beep boop, beep boop, beep boop, meow meow, meow meow, beep boop, beep boop, beep boop, meow meow, meow meow. Z's. Now we go in InfraWorks, go to new, call this one Pines Village site, work local. In coordinate system here, we're going to choose UTM-8415N. In model extents, define model extent using site topo. Click OK. Again, go into model properties, define the extent using this load extent from file, Aaron site bounding box, use first polygon. OK. Then add in the raster for the topography. So topo, this uses UTM-8415N, close and refresh. And then we're going to add in the aerial raster, this one. Okay. what you do is in GIS, we need to edit this TIFF file here. And before you edit it, you need to basically ensure that after you edit this file and then bring it back into GIS, it still has its geolocation metadata associated with it. There is a tool called Export Raster World File. Click on that tool. So click on that folder icon, browse 8724 right here, then choose run. And it looks like nothing happened. But basically, we've exported out some metadata that remembers the dimensions of this raster here and makes it so that if we bring it back into GIS later, we can realign it. So I'm going to remove this from GIS. I'm going to right click on this, remove. And I'm also going to do this step as well. I'm going to save the file. I'm going to close GIS. So we're going to open Photoshop. Let's also open Google Earth. In Photoshop, bring in that TIFF file. I'm also just going to quickly just look at this real quick to make sure that I'm only capturing the area that we need, which is kind of this space right here. Something like this is what we need. So what I do is in Google Earth, I go to View in Google Earth. I go to Reset, Tilt, and Compass. Choose the Save Image button. And then in Resolution, you just choose the maximum resolution. Then choose Save Image, Greenway. What you do in Photoshop, go to File, Place Embedded, bring in that export. So now that you bring that in, then you take this and you kind of need to blend it into the background. So what I do is I click on that layer there, I add a mask, then I use the mask brush to fuzz out parts of the corner. So once you have that, I'm going to copy that layer in the layer panel on the side. So you have two versions of that. On the one on the bottom, I'm going to set that to be luminosity. Then I take the top layer here and I create a soft light, adjust the opacity of that just a little bit. Or maybe even just like a normal would work as well. And then basically what you do is you take all the layers here, merge them together, merge layers, then hit save. But it's not saved. So we now can close out of this file here. And I'm going to open GIS, go to your catalog, refresh the folder that the file is saved in, then bring it in. Go to geoprocessing, type in define projection, choose that tool. In the first line here, choose that aerial file in a coordinate system, which says unknown. Simply set that to be the UTM-84 system. Pick another file that already has that, then choose run. And there it is. One thing you'll notice, if I zoom into this, you see that it doesn't look like anything has changed. If I zoom in closer, eventually it does change. That is because of the pyramids. We need to update the pyramids. Just type in pyramids, choose this build pyramids option, then choose the raster data set we just updated, then choose run. And now you see the Greenway is in there. And then go to InfraWorks. And then in InfraWorks, all you need to do is go to the data sources, click on that link, right click it and refresh it. So let's add in the buildings, add shapefile, Aaron site buildings right there. So add that in there, choose buildings, choose the Z value in the expression editor, choose meters, height above sea level, choose a white color, paste that into the other lines, go to source, drape it. I'm going to add a roof slope of 33, pulse and refresh. Let me do this now. We're going to bring this into Rhino. So what we do is we go to present, share, export 3D model. So we're going to check this use entire model box there. In target coordinate system, we're going to choose LASF, Louisiana South feet, because I want the units of the model to be in feet. Here, we just choose user find. You remember these numbers here just so that in case you need to bring in GIS data, and then choose multiple files. And then in ground, choose that folder, save the files as OBJ. So ground will be ground AS, and buildings will save it as buildings AS. Make sure this export materials and textures is checked. And then also uncheck this, merge objects with the same texture, and then choose export. Okay, I'm gonna do that one more time, but I'm gonna do it now for the other site. Export 3D model, check use entire model, LASF coordinate system, choose user defined, check multiple files, choose OBJ, call this one ground VS. Export materials and textures, and also uncheck merge objects with the same texture and choose export. So let's go open Rhino. And then we're going to import one of those models. So first thing I do is I just check my units to make sure that we are in feet. So I just type in units, choose feet, click OK. And then we're going to import and we'll choose the ground VS OBJ open. Make sure map OBGY to Rhino Z is checked, click OK. You can go to a rendered view, or you can create your own custom view that allows you to view textures. This site turned out to be quite large as one. And you can also see that because we added that road layer in, it comes in as a kind of a split feature from that. There's a few steps you need to do. Number one, organize it into road tiles and just ground tiles. So the first thing I'll do is I just simply select all the tiles that are the roads. So when you have all the roads selected, I just hit Control G to group them together. And then I select this group here and I change it to a new layer. So I just right click on another layer, change object layer. And now roads are its own layer. Select everything else, group that, then change that to a new layer. The other thing that I recommend doing is optimizing this mesh here. So you see this mesh, even though we've optimized it into a 2-meter resolution, this could still do with more optimization. So click on the mesh layer here, then choose Reduce Mesh, and then reduce it by 50%. Click OK. So that's optimized now. In the past, I've done this whole grasshopper thing where you take your contours and you turn it into a surface. I've been really stupid the whole time. There's actually a way easier method to create a surface out of all this. First thing you do is we need to take this image here and we just need to rectify it so that it's square with the image. So the way to do that is I'm going to click on this here, type in duplicate border. So that just kind of creates a little grid. Move this grid from one corner to the origin like so. And then in top view, I'm going to type in C plane. And now we're going to rotate the C plane. So choose rotate over the Z axis as our first reference angle. We're going to just choose the X direction like this, hold in shift. Then you see what happens is now I'm rotating the grid like so. So now the grid has rotated. And then we're going to top view, go to this arrow here, go down to set camera, then choose C plane top. And now you've basically done a rotation of the image so that the aerial now is square and aligned with the frame here. And then what we're going to do is I'm going to create a layer, drape surface. Make sure you only have the mesh turned on, then just type in drape. Then just simply don't move the window, just click and drag. That's it. Then you can turn off the mesh and now you have a surface of your site. If you type in drape one more time, you see spacing is set to 5. You can make that smaller. And so you can basically adjust the resolution of this surface. So if you choose that and maybe choose like 2, that will increase the resolution of the surface. And one thing that you notice are these little dimples in the landscape. The drape is looking for something to hit, but occasionally it finds a spot that's kind of at the joint between one feature and another feature, and it actually just kind of misses it. You can fix that by simply just turning on the points for the surface. So PON for points on, and then just simply going in here, set point tool to bring it up to like a nearby point. That's it. Let me just turn on the mesh again and let's turn off the surface and let's bring in the buildings. So import buildings. So typically buildings come in as meshes. You see these come in as meshes and those are really hard to edit. Just select all the buildings, join them together. So type in J to join them. So now it's all one mesh. Then once you join them together, then you kind of split them out again. So select them all again, then choose split disjoint mesh. So now all the buildings are individual buildings. And then you use a tool that I know some of you have known about for a while, this mesh to NURB tool here. So type in mesh to NURB. Then turns all the meshes and it turns them into surfaces. Then type in select mesh. So it selects the meshes, delete those. So now you only have the NURB surfaces. And then you simply select the last step, you select all these here and type in merge all coplanar faces. That cleans them up. Getting to this point here, you basically now have a clean base model. Let me create a thing called a section surface first. So I'm going to create a layer called section surface. And then in section surface, we're going to draw a vertical plane that kind of represents where you want that section cut to be. So a section like that is probably what we want. So what I'm going to do is I'm going to go to a top view first. I'm going to create a vertical surface. So in the tab on the side, I'm going to choose the surface button there and then choose this vertical plane tool. And now basically you pick an area. Let's say this is the area. Then we're going to draw kind of roughly where we want our section to be. Let's say this is it. Then go to a perspective view just to get that vertical height of that section plane. This here is mainly being used for an orientation device where we can set the camera to face this plane with a planar orientation. Do one quick thing. I'm going to take the surface here. I'm going to create a new layer called reference. You don't have to do this, but I'm going to use this just to illustrate a point. And I'm going to create a grid out of the surface here. So I'm going to type in contour. I'm going to contour this vertically. I'm going to contour this horizontally. And then what we're going to do, I'm going to turn that off for a second. I'm going to create a clipping plane. So a clipping plane, I'm creating a new layer, call it clipping plane. I'm going to give it a red color because you'll see why in a second. Make that your current layer, then type in clipping plane in the command line. And we're going to draw a vertical clipping plane. So choose vertical, then just simply use this rectangle as your kind of your grid. And you can see once we finish the clipping plane, you've essentially created a section cut through the model. Now, this clipping plane here, if you move it around, it kind of cuts through the model wherever that's located. We want that clipping plane and that surface to be coplanar for one very specific reason. So let's move it to some location. Eventually, you'll pick an area to cut. Let's say the area that we were kind of at right here. You can use a tool in the Set View tab right here called Look at Surface. So I choose Look at Surface, then you choose that surface there. I got to choose a corner of it. And then just pick somewhere on that surface. And then what's happened now, let me turn on that reference grid again. This grid here, as long as I only pan around the model, I don't rotate, this grid is always planar with the front of the page. So this is how you create those planar section perspectives where the actual section itself does not have any distortion in it. If you begin to rotate it, so I'm going to just rotate around the model like this, then the section has the distortion to it. And so one of the decisions you'll have to make as part of this assignment is whether you want your section perspective to be 3D like this, or if you want your section perspective to be planar like this. Both of them have their advantages and disadvantages. So you can choose which one makes sense for your particular project, whether you want a planar section like this or a 3D section. I might recommend for you all to do both. Maybe do one planar section like this, which is a bit more of a traditional section, then one 3D section, which is a bit more dynamic and more of a perspective. One emphasizes the section, the other one emphasizes the perspective, but both of them are section perspectives. The other thing that you can do is if you want to adjust the tilt a bit so that you have a bit of a higher elevation, what I recommend you do is you go into the viewport properties. So I'm just going to go to the little properties on the side here, the little properties rainbow. In projection here, choose 2-point projection, 2-point perspective, choose that. Now, if it's set to 2-point perspective, what you can do, and hopefully you can see, I don't know if you guys are looking at my screen, but I'm pulling my keyboard. This is my keyboard. This is a really nice keyboard, by the way, in case you aren't looking for a keyboard to buy. It's this Logitech MX keyboard. It's a great keyboard. If you use your arrow keys, the up and down arrow key, okay? I'm gonna hit those arrow keys. That's how you like add that perspective. But again, you see the actual section itself is still planar with it. So this is how you begin to really hone in your view. You can say, for instance, if you have a design project that really is emphasizing the ground condition, maybe you want your view to be lower. If you have a design that you really want to show the scope of it, you might go for a larger view to view like this. But the whole point is that with this method here, you can create a planar section that is dimensionable, that is measurable. You can zoom into it and pick the right angle, and you can use those arrow keys. So what I recommend you do is just save a view. So go to name views, hit save as, and then save it as like section perspective. I spelled perspective wrong. We'll call it section perspective. The minute you rotate this, you lose it. So just go back to section perspective and then you're back. That's how you make a section perspective. What I wanted to get into here was the process of beginning to add detail to your context so that as you begin to create your section perspectives, you have the detail and the information that you want. Obviously, adding things like people and plants and scale figures, and essentially for most plants, you can just use the Enscape asset library. The way you do that is just go in here, click on the asset library here, and then you just pick your assets and you can add them to the model. You go in here and then you pick, for instance, a vehicle. Say you want to put a car into the model and pick a car. And then Enscape assets only like to be attached to surfaces. So that's where the Drape surface comes in handy, because then you can just plop it straight onto that surface there. Some of you, like I said, are working within sites that are at that really tight neighborhood scale where understanding understanding the actual condition as it relates to the actual front of the house might be important. And so there might be a need for you to get more detail in the buildings. So I'm going to show you a few techniques that you can use. And each technique will tailor towards a specific, let's call it use case for what you want your section perspective to show. Just very simply utilizing the context that you can get from Streetview, like this here. Whenever we create like these kind of perspective renderings, a lot of times what we try to do is we try to pick a view and find an area that we think could actually work well as a section perspective, and then utilize this as essentially as our background. Go into here and just choose save image, and then just choose an image. And what I recommend doing is picking like 2 images, like for instance, like this, then choose save image, view 1. Then kind of rotate it a bit. Save image, view 2. So you go to Photoshop, automate, photo merge. So what you would do in this case, we just simply trim this to be a simple perspective. There's a portion of this where the perspective gets a little bit out of hand, like right around here. This is where I might cut it off. So we'll save as AS for Aaron site, Pano. Okay, so in Rhino, what I will do is I will go into a wireframe view. This area here is kind of where that photo was taken from. So what we're going to do is we're going to go into the properties view here, and we're going to choose the wallpaper option down here, choose those dots there, and you're going to find that panoramic image. So this is basically what you do is you need to kind of align the buildings that are within that frame to the image here. So this building, that building, that building. And I'm just gonna move that to a new layer temporarily. So change object layer, then turn off everything else. So now we can use these elements here to align the image to the actual model line work. So I'll go to a wireframe view here. An image like this is super tight lens length. So let's try 15 to start and see how close we can get. And all I can say with you guys is that this is not a science. This is just quite literally going in here and fudging it until you get something that feels somewhat close, and you need to adjust, kind of go here, go back here and adjust it. So right now this might be a little bit too dramatic. So maybe try 20. Let's see if that comes closer. Maybe let's increase this to 20 or go to 18. Let's see if that helps. Yep. The lower this lens length here, like if that number decreases, the more dramatic, the more wide angle it becomes. And then the higher that number becomes, the less dramatic, the more flat the image becomes. So once that's kind of where it is, then just go here, save as, call it section perspective. So then with that set up, basically what we do is we'll go back to a top view, go in here, create a section surface. We'll click on that. We're going to create a surface around the area that we want to create. We want to create that cut. And then we choose clipping plane, or rather we create a clipping planes layer, clipping plane, then type in clipping plane, vertical, like so. And then you can turn the mesh back on, you can turn on buildings back on, everything else that you turned off. This you can turn off as well, and then go back to that view section perspective. Right now, the clipping plane is not set to this. So basically you just click on the clipping plane right there, and then make sure that's section perspective is checked. And now you can sort of see that this is where the section perspective is cut. So in this case here, this perspective is really dramatic. I go to a shaded view here, you can begin to see that the mesh is kind of close. But then basically what you do is when you render this out, what you're really rendering is the elements along the surface, and then you kind of use Photoshop to get bits and pieces of the background into the image. What we'll do is we'll fire up Enscape. So go to Enscape, choose. So what we'll do is when you have Enscape open, you can turn on the mesh. We'll just simply utilize a white texture look. So I'll go to Style, White. We'll call this the foundation of our section. If the clipping plane isn't actually cutting this section, just go click on the clipping plane, go to properties, and then make sure that this section perspective view is checked. And then you're almost ready to export some stuff out. So what we'll do is we'll go into the safe frame here. So make sure that the safe frame is turned on. We're going to go to the visual settings here, and we're going to set the output to be a resolution that we can work with. So I'm going to set this to be 6,000 by 4,000. That looks good to me for now. Close out of this and I'll render this out. So choose screenshot for rendering. Okay, and then Enscape, for now, we don't need anymore, so I'll just close out of that. And then Rhino, we need to export out line work. So what I'm going to do is I'm going to turn on the surface layer for now. I'm going to turn off the clipping plane just so that we have a cleaner base to work off of. But basically what you would do is you would right click on this guy, hit print, and you would print out a line work base that you can work off of. I have a giant cat as well. So if you want to go back and model a building a little bit more detail, you do need to have some reference imagery to use to kind of get it right. And if you don't have drone imagery, if you don't have like a nice photo of the whole building at once, the best resource that we do have is just simply, Google 3D model here. And so this method here is, I would say, if you really just need to get more detail in the building itself. So let's say you want to pick one, let's say this building here, for instance. So what I would probably do in this case is I would basically kind of pick an angle here. I would grab an image so that you have a little image. So what I'll do is I'll simply go in here, choose wallpaper, choose image, and then you find that building that you are trying to add more detail to. So this building here, again, what you're trying to start is to get this sort of aligned with the background image. And then now you can sort of begin to align this with the image like so. And because, this building here does not have as much detail in its, when it was created in InfraWorks, it doesn't fully align totally with the image. First, once you kind of get your building kind of lined up, you want to lock in the properties panel on the side, choose this lock checkbox on the side under projection. That makes it so that when you try to rotate, it doesn't move anything in the view. So now it's kind of like locked. And then what you can do is you can utilize the solid modeling tools in the solid tools tab here, the top here, to begin to shape and refine the building a little bit more. One thing that comes in handy is to always make sure that you're working within the C-plane surface plane that you want to edit. Basically, let's say, for instance, right here, you can see this building face right here, and the roof pitch here actually extends all the way to the front of the face. So what you do is you type in C-plane in the modeling tool here. You choose surface in the C-plane options. Then you can pick any surface in the modeling world, like this one right here, for instance. Then you can set a C-plane right there. And so when you draw or you edit or anything, you can actually edit within that plane itself. And then what you do, let's say in this case, want to edit this, you click on the building here, and you choose this solid control points function here to get like all the control points of the model. Then you can take, say, for instance, this point here, you can move it, type in M, and you can choose vertical, which is a bit counterintuitive, but now what that does is it allows you to adjust that to the vertical of that particular plane. You're now beginning to kind of edit the actual building itself. You can always go back and forth between, say, for instance, a shaded view and a wireframe view to begin to see what you're doing. If you want to get, for instance, like the little porch in there, you can use a tool called wire cut, and you can begin to like slice through it. So here's how that would work. Draw a box on that plane there, kind of that porch there. And then you click on that, then you choose the wire cut tool, then choose this as the object to cut, then choose enter. Then you can actually cut into the building like that, and then hit enter and turn on a shaded view. You're beginning to now like modify and edit the building slowly. Here is actually my real recommended method. Instead of actually like going through the process of modeling buildings, I'm gonna go to this website here called Sketchup Warehouse right here. And you just search for New Orleans shotgun house, go to models, and you might find a building that comes close enough stylistically to, say, for instance, a building that you need your work. I have shown some examples last semester, the studio group of examples of the kind of models that you can make. These are the kind of models that I built, these linear greenway models that are within the right of way. All this work here is derived from a site plan first and foremost. I drew this first. In this case, this is the plan of a trail. Then I used this plan to get all the elements of the design in 3D. It's only possible to get to this level if you arrive at a complete design concept sooner. That's what this assignment is meant to do, is meant to help you get to a design concept sooner, but at the the scale of a section here, because you're forced to use the model and you're forced to zoom in to the design. And then, as always, oh no, Mimi. My headphones. She got tangled in my headphones. I'll see you guys next week.